Bismillahirrahmanirrahim. Today we are going to have a lecture about the computer animation. This is the lecture number 10, and in this lecture we are going to discuss the following topics. We'll discuss the definition of computer animation. We will discuss the principles of animation. What are the basic principles on which the animation is based? There is a kind of animation which is called the keyframe and in-between animation. So basically we are going to discuss this type of the animation in this lecture. And then in the animation, sometimes the animation have a constant speed, so we will discuss about the constant speed animation. And sometimes the animation is not constant speed, but the speed is going to be changed, either it can be increase or decrease. So we are going to discuss this type of the animation which is called the accelerated animation. So now let's start the discussion of these topics. First we will discuss about the definition of the computer animation. Animation is a visual change over time. So in the animation, basically we are changing the visual representation of the objects over the time. Means that over some interval of the time we are changing the appearance of the object. For example, in this picture, in this figure, you can see that we are showing the cartoon character, and this cartoon character is walking. So when we want to create the animation for this walking sequence, we are going to show that the character is moving gradually. So in the animation it is important that when we are changing something, these changes should be gradual, not very rapidly, otherwise it will not create the effect of the animation. For example, we can divide this animation into the multiple frame. This can be the frame number 1, here we can have the frame 2, then frame 3, 4, 5, 6, 7 and the 8. So we will start from the frame 1 and we will go until the frame number 8. So initially we will show the frame 1, then we are changing the object in this figure, the cartoon character, and you can see that the feet of the character is moving gradually. So in order to show that the cartoon character is moving, we have to make the changes in the cartoon, and these changes should be gradual. So and when we are going to show this animation with certain speed, that how many frames we are going to show in 1 second. For example, usually we show something like between 25 and 30 frames per second. The meaning is that in 1 second we are showing the 25 or maybe 30 frames, and when these frames are shown in the sequence from frame 1 until the frame 30, and these changes are gradual, then the viewer is going to perceive this thing as something is gradually moving or changing, like a computer animation. In animation, a series of images are rapidly changed to create the illusion of the movement. As I told you that in 1 second we are usually showing the 25 or 30 frame or maybe more than this thing. So it means that if we have to create the animation of the 3 second, and in 1 second we are going to show the 30 frames, so the meaning is that in the 3 second we have to create the 90 frames. In each second we are creating the 30 frames, so for the 3 second we have to create the 90 frames. So lot of data has been created in the computer animation. So animation could display the time variation in the object's position, orientation, size, color, texture, or the illumination. So when the object is doing some change, when we are doing some changes in the object, so these changes can be of various type. For example, the object is moving from one place to the other place, this is a change in the position, or maybe the object is doing a kind of rotation, or maybe we are changing the size of the object. Maybe initially in the frame 1 we have a smaller size, then the size is gradually increasing in the frame 2, then further increasing in the frame 3. So the various kind of changes can be shown in the animation. So this is the concept of the computer animation. Now let's move to the next slide. Principles of the animation. The animation is based on the principle which is called the persistence of the vision. Persistence of the vision is the phenomena of the eye by which even nanosecond of exposure to an image result in the millisecond of the reaction site from the retina to the optic nerve. Meaning is that when we are showing some objects, some frame, some images to the human eye, then even we are removing these frame, but the effect of the frame or the image remain in the brain. So when we are using this principle and we are showing the frames very rapidly, then the humans are going to perceive that there is a consistency, there is a continuity in the animation, and object is moving smoothly, but it should follow some rate, how many frames we are showing in 1 second. For example, we can show the 30 frames in 1 second. If we are going to show less number of frame, then the precision of vision will create, it will not be very smooth, it will create some kind of jerking, some kind of disruption in the continuity of the animation. So it is important that we take advantage of this phenomena, precision of vision, and we show certain number of frames and which are quite enough. For example, 30 frames in 1 second. So the human brain is going to think that, is going to perceive that this is a continuous motion. We are not going to feel the disruption in between the frame. So basically animation is a sequence of the frames and they are being shown at a certain rate. In the movies and the films, the frame rate can be something like a 24 frame per second. In 1 second we are going to show 24 frames. Now let's come to the next slide, which is about the type of the animation, which is called the keyframe animation. A keyframe is a detailed drawing of a scene at a certain time. So at a certain time, because we express this thing, we said this thing that we have to show the changes over the time, but at a certain time the changes are quite important and they are being drawn in detail, and this is called the keyframe. So for example, the frame 1 can be the free keyframe, then we are going to create the keyframe at certain interval. For example, we can have a keyframe at frame 1, then maybe at frame 11, then maybe at a frame 21, like this thing. So these frames are quite important. We are going to describe the detail of the scene in this frame very explicitly and very clearly. A keyframe is a detailed drawing of the scene at a certain time. Within each keyframe, each object is positioned according to the time for that frame. So whatever the position is there for the object, we have to draw the drawing, or we have to use some software to describe all the object in that scene at a particular interval. For example, in the frame 1, frame 11, frame 21, we are going to show the objects. How many objects are there does not matter, maybe one object or maybe more than one object. But maybe you will think that what about the other frame, for example like a frame number 2, frame number 3, frame number 3. So in the keyframe animation, we are going to generate these intermediate frames or the in-between frame automatically by some algorithm or by some software. So we are going to just define the keyframes, which are the important frames where the changes are quite important, and the frames which are between the keyframes, they are called the in-between, and they are going to be generated automatically by the algorithm. Keyframes are defined at a significance position. For example, we may have a keyframe at the frame k, and then we have a keyframe at the frame k plus 1. For example, I say that maybe initially we have a keyframe k is equal to 1, and then we have a keyframe k plus 1 which is equal to the frame number 11. So this is the frame sequence, frame 1, frame 11. In between frames are going to be calculated by some algorithm. So this is our keyframe 1 and this is our keyframe 2. But if we are going to count all the frame including that between frame, then this is going to be frame 1 and this is going to be the frame number 11. So let's discard this thing before we moving to the next. So here you can see that in the keyframe k, which is our initial keyframe, we are showing the 2 points, the point 1 and the point 2, and in the next keyframe, which is the keyframe k plus 1, we are calling this point as the 1 dash and this point as the 2 dash, and we are adding one more point which is called the point 3 dash. So there is some change is there between the keyframe K and the keyframe K plus 1, but these changes should be shown gradually. So we have to insert some intermediate frames between these two frames, so the changes should not be shown very abruptly between the keyframe. For example, let's see discuss about these intermediate frames. They are called the in-between. In-between are the intermediate frames between the keyframe. So we have a keyframe K and then we have the keyframe K plus 1. So between the keyframe K and the keyframe K plus 1 we are inserting one more frame, which is called the halfway frame. So this has been inserted so that the changes are gradual. So you can see that initially we have a point 1 and the point 2, and the intermediate point is being inserted, but this is not going very far away from the point 1 and the point 2. So our distance is gradually changing. So if we measure the distance, here the distance is smaller and here this distance is bigger. So there is somewhat keyframe intermediate frame is compensating for the sudden change. Here they are showing that we have only inserted the one in between frame, but we can insert more. For example, we can insert one more intermediate frame here, we can insert one more intermediate frame here. So we can insert many intermediate frames so that our changes are gradual. So here it's mentioned that typically there are 3 to 5 in between frames are there for each pair of the keyframe. So it depends on actually on the animator how many intermediate frame he want to insert between the keyframe. So the animator is going to define the keyframes, and then by some algorithm intermediate frames are going to be generated. Now the animator can specify that how many intermediate frames should be generated between each pair of the keyframes. Keyframe system generate the in between frames from the user specified keyframe. So the user is going to specify or maybe draw the keyframe, and the keyframe system is going to generate the intermediate frame, which are called the in between frame. Motion path can be specified with a kinematic description as a set of the spline or the curve. If we are showing that some object is moving, then in which direction, how the path is going to be defined for the object. In a very simple case, it can be the straight line, but usually many objects are not moving in the straight line, so we can specify the path of the motion by using some higher order curve. For example, we can use a curve like this curve, and they are called the spline. There are the different kind of splines are there. For example, natural cubic spline, cardinal spline, Catmull-Rum spline, B splines are there. So a bit advanced topic is there, which is also being used in the keyframe system to generate the motion path. Now let's discuss about the type of the animation, which is called the constant speed animation. So from the heading you can understand that in this type of the animation the speed is constant, speed is a fixed. If the motion is to occur at a constant speed, there is no acceleration, speed remain constant, zero acceleration, the equal interval time spacing is used for the in between. So in that case we are going to generate the in between frame, and the time spacing between the in betweens are going to remain the same. For example, here we can say that we have a first keyframe and we have the next keyframe, let's say maybe it is K plus 1. So in between these two keyframes we are generating the intermediate frame. So there is an intermediate frame here, 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 intermediate frame here, there. So 1, 2, 3, 4, 5. So between the two keyframes we are generating the 5 intermediate frames. So we have the keyframe K and we have the keyframe K plus 1. So we are generating the 5 intermediate frames between the two keyframes. But the important thing which we want to show here, or we want to describe to you, that the spacing between the intermediate frame remain the constant. So this is the spacing which is called the delta t. So you can take the spacing between any two intermediate frame, so this is going to remain the same. For example, if this is like a 2 second, so this will also be a 2 second, this will also be a 2 second. So this is called the constant speed animation. Now let's say discuss some example for the constant speed animation. For example, the time for the first keyframe is t1 is equal to 10, and the time for the last keyframe t2 is equal to 14, and we have to specify that how many intermediate frames are there between the two keyframes. So we have a two keyframes, keyframe K and the keyframe K plus 1. The timing for the keyframe first keyframe is t1 and the timing for the second keyframe is the t2. Animator define this variable. So this is n is equal to 9. So meaning that between the first and the second keyframe we have to generate the 9 intermediate frames. So we are going to use a variable which is going to start from the 1 up to the n. In our case n is equal to 9. So how we are going to compute the spacing between the intermediate frame, delta t. So the equation for the delta is t2 minus t1 divided by n plus 1. So in our example the value for the t2 is 14 and the value for the t1 is 10. So we are going to substitute this value, divide by n plus 1. N was equal to 9, 9 plus 1 is equal to 10. 14 minus 10 is equal to 4, 4 divided by 10 is equal to 0.4. So this is the spacing between each of the intermediate frame. Now we have to compute the time for each of these intermediate frame. So we are using the variable tbj. So this is specifying that timing for the in-between frame. So b is for the between and j is for the jth in-between frame, and our j is moving from 1 to n. So this parameter or this subscript is only specifying the number of the in-between frame, not the keyframe. So we have to say that our j is moving from 1 to the 9. So the equation for the tbj, that is meaning the time for the jth in between frame, is equal to t1 plus j multiplied by the delta t, and j is going to be changed from 1 to the n, from 1 to the 9, and delta t we already computed 0.4. So if we are going to substitute the value in this equation, so we are going to compute the timing for the in between frame. tbj is equal to t1 plus j delta t, the same equation. Initially for the first keyframe t1 is equal to 10. Now we have to compute find the value for the in between frame tb1. So this is the first in between frame, which is equal to t1, which is 10. It is not going to be changed every time. This is going to remain the same, plus initially j is equal to 1. Delta t will also remain the fixed, which is equal to 0.4. So 10 plus 1 multiplied by 0.4 is 0.4. 10 plus 0.4 is equal to 10.4. Now similarly we have to compute the time for the second in between frame. Only thing we have to change is the value for the j. The value for the t1 and the value for the delta t remain the same. So we compute this thing, 10 plus 2 multiplied by 0.4. So this is going to be answer 10.8. So we are going to compute the timing for all the in between frame from 1 to the 9. And then this is the timing for the next keyframe, the second keyframe, which is the 14. So you can see here in these values that you have an equal interval there. So 10.4 minus 10 is 0.4, 10.8 minus 10.4 is also the 0.4, 11.2 minus 10.8 is also the 0.4, because this is a constant speed animation. Now let's talk about the another kind of the animation, which is called the accelerated animation. Speed changes are essential for many animations. Trigonometric functions, spline, parabolic function are used to model the acceleration, deceleration. Acceleration means the speed is increasing, and the deceleration means the speed is decreasing. So we can model the acceleration or we can model the deceleration by some mathematical function. It can be the trigonometric function like a sine theta, cosine theta. It can be a spline, as I told you, many kind of splines are there: B spline, natural cubic spline, Catmull-Rooney spline, or there are some parabolic function can also be used to model the accelerated or the deceleration animation. Let's see some equations, some mathematics for this thing. So we are going to discuss about the accelerated animation, in which the speed is increasing. To model the increasing speed, time spacing between the frame is increased. So in the constant speed animation, the time spacing was constant, but in case for the accelerated animation, time spacing is going to be increased. So here, in order to model the accelerated animation, we are using the trigonometric function. So our function is 1 minus cosine theta. The value of the theta is going to be between the 0 and the pi by 2, greater than 0 and less than pi by 2. And the value of the theta, here we are using the theta. We have a equation, we have a formula for the theta. Theta is equal to j pi divided by 2n plus 1. And the value for the delta t is going to be computed by this equation. Here the delta t is not the same as we have used in the constant speed animation, so be careful about this thing. In the constant animation we compute the delta t, t2 minus t1 divided by n plus 1, but here in case for the constant accelerated animation, our delta t is going to be computed by this equation, t2 minus t1, and theta is going to be computed by this thing. Now, as in the constant speed animation, we have a equation, we have a formula to compute the time for each of the in between frame, which is called the TBJ. But the formulas are different for the constant speed and the accelerated animation. In case for the constant speed animation, our formula was this one, to compute the time for the jth in between. TBJ is equal to T1 plus J delta T. In case for the accelerated animation, the equation or the formula to compute the jth in between is this one. TBJ is equal to T1 plus delta T 1 minus cosine theta, and in fact the theta is equal to J pi 2n plus 1. So this whole thing is basically a theta, because we have defined the theta is here, and J is going to be varying the same as we have defined previously. How many intermediate frames are there between the two keyframe? So here J is equal to from 1 to n. So we can write the formula also in this way. TBJ is equal to T1 plus delta T 1 minus cosine theta, because I told you that this whole thing is a theta, and J is equal to 1 to n. So this equation or this formula is going to be used to compute the time of the jth in between frame. Let's see the some example for this thing, more detail about this thing. A trigonometric acceleration function and the corresponding in between spacing. For example, here we are using that we have to generate the n in between frame between the two keyframes. So the value for the n is equal to 5. When we have discussed the constant speed animation, the value of the n was in our example the value of the n was a 9. So there can be any value for the n, how many in between we want to generate. So by using the value of the n, we can compute the value for the theta, because let's see that what was the theta. Theta was equal to J pi divided by 2 multiplied by n plus 1. So we have the value for the n is there. So we are substituting the value of J pi divided by 2 n plus 1, and n is equal to 5. So J pi divided by 2 multiplied by 5 plus 1. 5 plus 1 is a 6. 6 multiplied by the 12. So the value of the theta is, we have simplified the value of the theta, J pi divided by the 12. Now producing the, let me move it here, producing the increase coordinate changes as the object moves through each time interval. As we have said that in case for the accelerated speed animation, the time is going to be increased between the in between frame. So for example, here we have an initial keyframe is a T1. So this is, you can say that we have to show the keyframe at this position T1, and our next keyframe is here, which is T2. In between these two keyframes, we have to generate the how many intermediate? 5. So you can say that this is the first intermediate frame, which we call TB1. This is the time for the first intermediate. This is time for the second intermediate frame TB2. This is TB3, and this is the TB4, and this is the TB5. So let me write one of these. So these are the intermediate frames are there, and you can see here, let me discard these changes and let me show you again. So you can see here, in case for the accelerated animation, the spacing between the in between frame is not the same. Initially we have the small space between the first intermediate and the keyframe, then gradually the spacing are increasing. So continuously every time our spacing is increased, because we are discussing the accelerated animation. And we have used the trigonometric function. If we are going to draw the trigonometric function, that is on the y-axis, we are using this function 1 minus cosine theta, and along the x-axis or along the horizontal axis, we are using the value for the j. In our case, j is going to be between 1 and 5. So for every value of j, if we substitute the value of 1 minus cosine theta, and you can see that the theta is based on the j. So initially j is going to be 1, then 2, then 3, then 4, then 5. Then our curve is going to be like this thing, and here you can also see that this spacing is increasing. Now let's see the example for this thing, complete example. Value for n is equal to 5, and delta t, as I told you that the delta is going to be computed T2 minus T1 for the accelerated animation. So T2 was a 6 and T1 was equal to 0. So we are discussing this example. So this is the T2. So 1, 2, 3, 4, 5, 6. So we have a T2 is equal to 6. So we can say that T1 is equal to 0 and T2 is equal to 6. So this is the 0. At time 0 we can start the animation. At the time 6 we are stopping the animation. We can start anything. We can start at 1 or 7 or whatever there. So here in our case we are starting the animation at the first keyframe, and the value for this time is t1 is equal to 0, and this t2, which is the second keyframe, is t2 is equal to 6. So here we substitute the value delta t is equal to t2 minus t1, which is 6, and for the first in between frame j is equal to 1. So first we compute the theta, we substitute the value for the j, and we already simplified the theta, j pi divided by 12. So just we put the value for the j, our theta is going to be pi by 12. And now we have to compute the value for the 1 minus cosine theta. So 1 minus cosine, the value of the theta is coming here, pi by 12. So we put the value, we substitute the value for theta pi by 2. So 1 minus cosine, value for the pi is equal to 3.142. We are using the value of the theta in the radians. So it can be used in the degrees, but right now we are using in the radians. So value of the pi 3.142 and then 12. So we have got the value for 1 minus cosine theta is 0.034. But the formula for the in between is this one, tb1 is equal to t1 plus delta t1 minus cosine theta. We have computed the 1 minus cosine theta separately so that we can easily substitute the value for this whole parameter, 1 minus cosine theta. The value of the tt is not going to be changed, this is going to remain the fixed. The value of the delta t is going to remain the fixed. T1 was a 6, sorry, t1 was equal to 0 and delta t was here 6. And 1 minus cosine theta we have computed 0.034. So 0 plus 6 multiplied by 0.034, we get the value for the tb1. Now what do you expect, what we are going to do for the time to compute the time for the second in between frame? What do you think? Maybe you can think before I move to the next slide. Yes, we are going to change the value for the j. Again we are going to compute the theta, we are going to compute the 1 minus cosine theta, we are going to put the value in the equation for computing the tb2. So here the same thing is going to be described here. J is equal to 2, we compute the theta, which is coming as pi by 6, because this time our value for the j is 2. So we can cancel 2 1 are 2, 2 6 are 12. So we are coming have a value pi by 6. Similarly we compute the 1 minus cosine theta, the value of the theta is coming from here, and we have computed the value for 1 minus cosine theta. We are going to substitute the value for 1 minus cosine theta in the main equation for the intermediate. The time for the intermediate frame, t1 will not change, delta t will not change, only 1 minus cosine theta is going to be changed, which we have computed here. So we computed the tb2. Similarly we are going to compute the tb3, j is equal to 3. Similarly we are going to compute the tb4, j is equal to 4. And similarly we are going to compute the tb5. I did not show you the computation for the j is equal to 5, but of course this is going to be similar. And then finally we can create the table. Initially our keyframe is going to be shown at the time 0. The second keyframe was at the time 6, and we have computed the timing for the in between frame. There was a 5 in between frame was there, n was equal to 5. So we have computed the tb1, tb2, 3, 4, 5, and you can see that if we are going to subtract the value of the tb1 from the tb2 and then we subtract the tb2 from the tb3, the timings are not going to be remain the same, they are increasing. For example, the difference between 0.8041 and 0.2045, if we compute this difference and we compute this difference, then this is going to be the larger, because this is the accelerated animation. So what kind of question can be asked? So the question can be something like this thing: find the values of the animation interval using the trigonometric acceleration function, fill the table shown below, draw the curve of the j along the x-axis and 1 minus cosine theta along the y-axis. We also show you here we can compute this curve. Along the x-axis we have the j, and along the y-axis we have a 1 minus cosine theta, and every time we have computed here 1 minus cosine theta is giving different values. So we have to, in the curve we have to substitute these values. 1 minus cosine theta, when j was equal to 1, it was 0.034. When j was equal to 1 minus cosine theta was 0.1340. When j was 3, 1 minus cosine theta was equal to 0.292. So these values can be used to draw this curve in the question. So here the question says that draw the curve of j along the x-axis and 1 minus cosine theta along the y-axis. Use the value of the theta in the radian. So what is given in the question? The value of the pi is given, n is equal to 6, means that there are the 6 intermediate or the in between frames are there. So the j is going to be vary between the 1 and the n. Initially t is equal to 0 and the t1 is equal to 0 and the t2 is equal to 7, and delta t is equal to t2 minus t1. So this can be, I say that anything, maybe we start at 2 or something, but usually we start at 0. And the equation for the theta is j pi divided by 2n plus 1, and the equation, the most important equation to compute the time for the jth in between, tbj is equal to t1 plus delta t multiplied by 1 minus cosine theta. So the value of the j's are going to be written here: 1, 2, 3, 4, 5, 6. You have to compute the value for all of these things: theta, 1 minus cosine theta, and the tbj. So once you compute all of these values, your table is going to be like this. And then finally you can draw the curve. Along the x-axis we have the j, which is initially we have the timing for the first in between, tb1, tb2, tb3, tb4, tb5, tb6. So these values are being plotted here. For example, the tb6 is equal to this one, because here we are plotting the 1 minus cosine theta. Here we are plotting 1 minus cosine theta. So if we take this value 1 minus cosine theta at j is equal to 6, so this is the value for the 1 minus cosine theta at j is equal to 6, which is 0.7776. so this value is showing this value. Similarly, 1 minus cosine theta at j is equal to 5, j is equal to 5, this value is 0.5662. So this value is here. So we can draw the curve between the j and the 1 minus cosine theta, because we have used this function to create the accelerated animation. Of course there is an equation for the theta, but the main equation for acceleration is the 1 minus cosine theta. So this is the end for this lecture. Thank you.